Swayam Prabha. Digital India. Educated India.
So, in the previous session, we stopped after calculating the truth value, the reference of this branch and this branch, and we have we realized that the entire branch has this reference. It is actually the reference, the denotation of Snows, and this branch has this reference, which is the denotation of Sadie. We saw this in the previous session. Now we need to calculate the truth value of this node, where these two things travel up and make this node, and then what happens? Now you see, rule 3 is the rule we now require to understand or calculate this case, where alpha is n goes to something like this. Alpha is n goes to something, and beta is VP goes to something, which is like this. Then in this case, alpha and beta are understood. So this entire thing is alpha and this entire thing is r beta. If that is the case, then if gamma is s and s goes to alpha beta, and we can see that yes, it is true that this is s goes to alpha beta. So this is our gamma. If this is the case, so if this entire thing is alpha, that is if this thing is alpha, and if this is beta, and if this is gamma, then the rule says that then the reference of gamma, that is the reference of this entire node, the reference of this s goes to alpha beta, or in other words s goes to n and VP, will be this thing. That is, what is the reference of gamma? Gamma is the entire branch. What is the reference of this entire branch? It will actually be the denotation of alpha. It will actually it is actually the result of giving the denotation of alpha to the denotation of beta, which is actually a function. This is beta. We remember that this is beta, or this entire thing is beta, and this is alpha, right? And what is the denotation of beta? It is actually this. So actually then what is the denotation of gamma, which is the entire thing? So the denotation of gamma then, according to the rules, will be the denotation of beta, which is Snows, and then that takes another thing, the argument that the argument the function takes is the denotation of Sadie. So then, so now you can see that gamma is the entire sentence. Gamma is the entire sentence. And what is the denotation and what is Snows? We just go back to the construction of these things. So basically Snows is this. Anwar Sadat, that is Anwar Sadat is mapped to 1, Elizabeth is mapped to 1, and Henry Kissinger is mapped to 0. So basically this is saying that Sadie snows and Elizabeth snows, whereas Henry does not. So we copy this, we just remember this entire thing, we get back to our exercise book and copy. So, AS snows and QE snows, whereas HK doesn't. Now, what is the reference of SADI? The denotation of SADI, it is actually AS, and then finally what we get is 1. Now AS is taken by this, and finally this is the result of it. So, the point is then the entire sentence, alpha is the entire sentence, which is SADI snows, and the reference of that, which is actually sentences. What is the reference of a sentence? It's a truth value. Now it is really truth value. I was always confusing truth value and reference. It is because of this. The reference of a sentence is a truth value. Now it is 1. We have calculated the truth value of this. Now we go to the other part, that is this part. This part we haven't considered. Now, if alpha is a VT goes to something, now we can see that here is that alpha is VT goes to something, and if we are considering rule 4, and if beta is n goes to something, and beta is n goes to something, then if gamma is VP goes to alpha beta. So, basically if gamma is this, if this is gamma and this was beta, then what will be the truth value of this thing, that is VP the entire branch VP goes to VT and n. What will be the truth value of that? By applying rule 1, that is by applying this rule, we determine the truth value of this, that is VT goes to loves, and it will be nothing but loves, that is that the denotation of loves will be the denotation of alpha, the denotation of Liz will be the denotation of beta. Now we don't know the denotation of gamma, what it is. We need to calculate that. So, now according to this rule, that is rule number 4, gamma will be the result of applying or the result of giving this argument, that is the denotation of Liz, to the denotation of loves, right. So, according to this rule, then what is this gamma? In our case, gamma is actually loves Liz, and what is it? It will actually be loves. So, alpha, the denotation of alpha takes the denotation of beta, which is Liz in our case, as an argument, and what will be the result? We take this, instead of doing it on this page, we can calculate it here, that will be easier. So, if we remember, we know that this is the object and this is the subject, that is this person loves this person. So, this is how it is, this is arranged. So, this is the lover and this is the beloved. So, that being the case, this is just loves. We need to understand loves Liz. We are calculating the truth value of loves Liz. So, what is Liz? Liz, it is nothing but Queen Elizabeth, that is this Queen Elizabeth II, and what is the result? This function this function, this entire function takes this as an argument, and the result, you see, we are not considering, imagine that, imagine this is just not there, this is not there, we are just talking about this. So, this is loves, which is a function, takes q e as a truth, as an argument, and what will it generate? It will generate this thing. So, the result of this will basically be another function. What is it? It will be this function where a s is mapped to 0 and q e is mapped. Remember, q e is an abbreviation for Queen Elizabeth 1, and Henry Kissinger is abbreviated as HK 0. This is the function now we have to carry to our page where we are doing our computation. So, we are actually here now, we are now considering this. Now, this is this function now, where once again where a s, so it is 0 1 0 actually. So, 0 q e 1 and then h k 0 0 1 0. This is the reference of loves Liz. So, it is not a truth value, it is another function. It is because loves Liz is not a sentence, it is just a part of the sentence we are considering. We are considering the sentence Sadie loves Liz, right. And then we are now here, we are at this level, we are at the level of s goes to n and v p. So, now where is s goes to n and v p? It is actually pretty much here. Rule number 3 will once again cover this case. So, what is it? If alpha is n goes to something, which is here, if alpha is n goes to something, and if beta is v p goes to something, we can see that this perfectly satisfies it. So, beta is, so this is alpha and this is beta, and if gamma is s goes to alpha beta, which is this. So, if gamma is s goes to alpha beta in this case. So, yeah, we have this is an old gamma, we do not require any more old alpha, and we should not confuse all these alphas and betas because this was the old calculation. Now, we are calculating a fresh set of things, and then here it is a case of s goes to n and v p, the third rule, which means that what will happen now is the truth value of this. Now, this precisely means that this is the entire sentence. So, this actually is Sadie loves Liz, right. Now, according to this rule, then we are considering this this rule. Then, if so all our conditions are fulfilled, then gamma is this entire thing, and the truth value of gamma is something we need to understand. It will be beta. So, this is alpha and this is beta, right. It will be the reference of beta, the function, and then it is the combination of these two and the reference of alpha, right. So, which means that it will be actually loves Liz is beta and alpha is Sadie. So, loves Liz now will take loves Liz will now take the denotation of Sadie, right, and loves Liz is actually this function. We have seen that previously, that is a s goes to 1, q e goes to 0, sorry, a s goes to 0, q s goes to 0 1, and hk once again goes to 0. So, it is 0 1 0, and then the denotation of SADI is AS, and then as a result of that it gives us 0. We say that which says that SADI does not love Liz. We can see once again, we can get back to the structure of loves and see whether, verify whether this is true or not. It is here. Now, you see it is pretty true. So, Liz is Queen Elizabeth, right? So, now we can see that this is the object, and the subject we have to look for Anwar Sadat. So, now you see SADI actually does not love Liz, because this combination gives 0. So, that is the reason. So, as a result of that we get, so we calculate and we find that this part comes out to be 0, and SADI knows this part comes out to be 1, right. Now, we need other rules and all that stuff. We now need a rule that has OR as its part, right. So, what is the rule? Now, we go there, the conj rule. Just a second. If alpha is a conj and phi is s goes to something and xi is s goes to something, then if omega is s goes to alpha phi alpha xi, then the reference of omega is this thing, right. Now, we know the structure of OR. So, what is the structure of OR? Already we have seen. We do not mind doing it again. It will be 1 1 goes to 1, 1 0 goes to 1, 0 1 goes to 1, and only 0 0 goes to 0, right. This is the structure of OR. OR is a conj, that is fine, and two sentences we have here. So, one is phi, our phi is SADI, our phi is SADI Snows, and our xi is SADI loves Liz. So, phi or xi is now actually the entire sentence, that is SADI Snows or SADI loves Liz. So, what is then the denotation or the reference of the entire sentence? That is SADI Snows or SADI loves Liz. Now, this will be so OR will come out. So, the denotation of OR, you see here alpha, this thing, the middle thing comes out. So, it is actually this function 1 1 1 1 0 1 0 1 1 and 0 0 0. This function now takes an ordered pair, and what is the ordered pair we are giving it? We are giving it, so we know that SADI Snows was 1 and SADI loves Liz was 0. This ordered pair, that is this 1 0, that gives us 1. So, that is how the truth value of the entire sentence will be 1, we have seen. So, this is how we can construct, we can calculate truth values of many sentences we can make, and we can also talk about those. Now, after having done these things, we can also make, we haven't used one rule, that is 5 we have seen all of the rules. So, 5 we need to consider. So, now we have done other rules, we have done 1 2 3 4 and 6. We haven't done rule 4 or no, we have done rule 5. That is what we need to consider. Now, we make a sentence whose truth value we know, something like SADI loves Liz. So, we are just making another sentence, which is, it is not the case that Sadie loves Liz. So, the construction of that will be S goes to neg and S, and then S goes to once again N and VP, VP goes to VT and N, VT goes to loves and N goes to Les. This N goes to Sadie and this neg goes to, it is not that, or it is not the case that, we just abbreviating it. So, our sentence now is, it is not the case, or it is not that Sadie loves Liz. We know that this is 0, I am sorry. So, this is actually, this is 0. Now, we have calculated that. We don't have to work on this area, we just work on this area. So, let us concentrate on rule 5, which says that if alpha is neg goes to something, now this is alpha, and if phi is S goes to something. So, phi is this, S goes to something, and we have seen that alpha is, yeah, neg goes to something. In that case, and if xi is S goes to alpha beta, we can see that, that's perfect. That is, xi is S goes to alpha beta. If that is the case, then what happens is, the denotation of xi, that is the entire thing, xi is the entire thing, basically the center of it, the top of it, or yeah, the very center, the very essence of the entire sentence, will be the denotation, it will be a combination of the denotation of alpha, and alpha we have seen is the logical connective, that is this. That will be the function, and the argument will be phi. So, and what is phi? Phi is actually this. If we see, this is phi, just need to do it. So, this is phi, this is alpha, and this is xi, this is xi. So, then the denotation of xi is the denotation of alpha, and the denotation of phi. We just replace these and we put our things here. We get what is xi. Xi is, it is not that Sadie loves Liz, and then alpha, if we remember, is neg, which is neg goes to, it is not the case that, and this is actually this function where 1 is taken to 0 and 0 is taken to 1, and we know that this is 0, right, we know that this is 0. So, that gives us 0 is taken to 1. So, 0 is taken to 1, 0 is mapped to 1. So, then the truth value of, it is not the case that Sadie loves Liz, will be 1 in our model. So, we know that the truth value depends on the model construction. The way we have constructed our model gives this truth value. It could be something else in some other model. So, we have we have actually considered each and every rule, and we have seen how the rules could be used. Now, we will try to solve some problems the book has given. So, for example, let us consider the first one. Yeah, this is enough, we need this much space. Okay. So, so what is the problem? The problem is this: suppose the phrase structure grammar we described were expanded to allow an adverb to modify the VP by adding the rules. VP goes to VP and ADV, meaning adverb, and then adverb goes to restlessly or harmlessly. That is, we are having two adverbs. Decide on an appropriate type of semantic value to assign to items belonging to the lexical category adverb and add the required semantic rule or rules. Though the same set of sentences would be generated if VP goes to VP adverb were replaced by SS, S goes to S and adverb, this syntactic analysis would have untenable semantic consequences. What are they? So there are actually two parts in the question. One, I find it a very brilliant question. So the two parts. One is write the rules. If you want to at all if you want to accommodate the adverbs, that is restlessly and harmlessly. So what is it we are writing? We are suggesting that the rules will be, the textbook itself suggests that the rules could be VP. We have seen that VP goes to VIN, that was one thing, or it goes to VT, sorry, there would be no N, or it goes to VT and N. Now there is another one, VP goes to VP ADV, and then they are saying that ADV either is restlessly or harmlessly. There are two adverbs they are adding. So the first part of the question is you add this syntactic rule, and then you so we have added this the syntactic rule for you. Now you have to add the appropriate semantic rule. So the semantic counterpart of this rule we have to add. That is one task. Another task is very interesting. That is something like this. They are saying that we are adding this rule. We are adding this VP goes to VP ADV rule, but the same could be done, the same effect, syntactic effect could be achieved by adding this rule. What is it? This is something like this. So suppose we have a sentence. So we see two derivations of the same sentence, two syntactic derivations of the same sentence. So yeah, one option is VP goes to VP ADV. Another option is S goes to S ADV. So the book claims that the second rule, the second option is a bad option. Why does the book claim that? So the book wants us to find reasons. The reasons for saying that, for claiming that this is a bad rule, this rule is a bad rule. So let us see why it is a bad rule. But first we see that both are syntactically, not syntactically, both are structurally good options. How? Suppose you have something like Sadie snows restlessly. We take a very simple sentence. How to derive it? There are two derivations. We take the first one, which goes like this: S goes to N and VP. Now VP goes to VP. VP can have three roots, as we have seen that VP can either go to VI, or it can go to VTN, or it can go to VP ADV. We just take the third root. So VP goes to VP, then ADV, and then this VP takes the second root, that is VP goes to VI, and VI goes to snows. that is 1, and say the adverb goes to restlessly, say, and n goes to Sadie. So, this is one option, and according to the book, the other option is something like this, that is S goes to S and ADV. This is also, it seems to be a good option, and then this S goes to N and VP, VP goes to VI, VI goes to Snows, and N goes to Sadie, and ADV goes to restlessly. Now, both seem to be good options, but the book says that this is the right option, because this option will have undesired consequences. What are those consequences? So, there are two questions. The first thing is adding the semantic rule, and the second thing is ruling out this option. We need to show that this is a bad option, option 2 is bad. How do we do that? First, we consider the first part of the question, that is adding the semantic rule corresponding to VP goes to VP ADV. As we said already, here is the sentence, and the sentence goes to NP VP. This will be the analysis, the syntactic tree for the sentence. So, then what will be the rule of it, the semantic rule corresponding to VP goes to VP ADV will be here. That is, if alpha is VP goes to something, if alpha is VP goes to something, and which is the case, alpha is VP goes to something, and if beta is ADV goes to something, which is here, then if gamma is VP, VP goes to alpha beta. So, this is gamma, this is alpha, and this is beta. So, it is gamma goes to alpha beta, then the reference of gamma, that is this, so remember it is the entire branch, all this fork, the reference of this fork, which is basically Snows restlessly, will be the reference of beta. In our case, beta is the adverb which is restlessly, and this will take so it is a combination, this will take Snows, or the denotation of Snows as an argument. Now, let us see how this works. We know this, what is it? We can copy paste, and it is actually very Snows. So, it is actually this, it is 1 1 0, that is Sadie Snows, then Liz Snows, but Hank does not, right. So, 1 1 0, we remember this, we carry this there, and then let us try to do it here. So, we know this. So, it is then restlessly is the function, or rather the denotation of restlessly, and we know this thing, this is 1, QE is 1, and Hank is HK, which is 0, this function. So, we can already see that here is a function which takes another function as an argument, right, and then what happens? We still do not know how this function, that is the reference of restlessly, would look like. Then how to actually construct this function, that is here. We know that the function Snows is this, that means only Sadie and Liz Snows, Hank does not. Now, suppose yes, both Sadie and Liz snore, but Liz snores restlessly, but Sadie does not, right. Also, suppose that Sadie hates Liz restlessly, although Hank does not. So, then the structure of restlessly would look like whatever, would look like this. This is the hate part. This is the hate part. We will come to this later, and this is the snow part. Can you see, this is actually the snow function. This I will talk about this later. Now, this complicated function is required because this function will take another function. This function will now take the snow function. What is the snow function? This will take this function as an argument, that is AS1 QE1 and HK0. And then after doing this, this will give you some other function which is once again required. What is this function? It is this function. This function comes out of it. Why? Because we said that although Sadie snores, he doesn't snore restlessly, whereas Liz snores restlessly, and HK must be 0 because HK does not snore at all. HK means Hank. Hank does not snore at all. So, if somebody does not snore, they cannot snore restlessly anyway. So, this is how we understand it, and then this is another function, right. This function will now take something and will return a value. So, we will see how the final computation goes on. We are here. Let us consider the sentence Liz snores restlessly. First, the generation of it, it is very simple. S goes to N VP, VP goes to VP and ADV, and N goes to Liz, and VP once again goes to VI. Just it is a simple thing. It goes to VI, and VI goes to snores, and ADV is restlessly. Our assumption is actually Liz snores restlessly. So, our desired result is 1. We shall see how 1 is generated. Now, we can see that according to our rules, according to this rule, here restlessly takes snores. So, then restlessly is actually this function, this big function. It takes snores as we have seen, and after taking snores, so actually how it goes. So, it actually happens this way. The steps will be like this. The steps will be like this. So, we have this whole sentence, Liz snores restlessly is actually snores restlessly, this function, this takes Liz as an argument, whereas snores restlessly itself is another function. How to understand it? This is actually restlessly takes this as an argument, that is snores, and then this function takes Liz as an argument, and finally the result comes out. So, we can see the result. So, the first part, this part, restlessly is this big function, it takes snores, it is this small function snores. The result is this function which comes out. Snores is given. There are other things also here on the LHS, but only one thing, because this gives this, right, it is the same mapping. Then it is this 110, 110, and as a result of that, this function comes out, where you have this 0 1 0, and after this, so then this can be written, this part can be written as this function which came out as a result. AES goes to 0 and QE goes to 1 and HK goes to 0 anyway. Then that function takes lis, the denotation of lis, which is actually QE, and the result is 1. This was the desired result. We can see that we need to get 1, that is the desired thing, because lis snores restlessly, but SADI doesn't. We can see how SADI doesn't, because instead of lis, if we had SADI, what would happen? If we had SADI here, it would be, we can also test that. It is very simple. Now this is common, right? Till here snores restlessly, this is common. So this function will come. After that, instead of this, we would just have SADI, which is AS, and then AS is mapped to 0. So as a result of that, we get 0 here, we get 0 here, and that is desired because SADI does not snore. So we can see that this complex function, this function which is the meaning of restlessly, is actually it has to be complex. This is just one part of it. What is the second part? The second part is another sentence. For example, if we have a sentence like let us consider Liz hates SADI harmlessly. We will consider this sentence, or no, just we would stick to Liz snores restless. This is done. We will consider, say, Hank hates Liz restlessly. We will consider this sentence now. So this is our next sentence, that is Hank hates Liz restlessly. First, the generation of this sentence, and it will look like something like this. Is goes to N and VP, VP goes to VP and ADV, and VP goes to once again VT and N. We are done. So N, the first N is Hank, and VT is hates, and N goes to Liz, and then here is restlessly once again, restlessly, right? So yes, restlessly once again. So let us see how we construct it. So we can see here that this part, the adverb restlessly does not take hates or Liz, it takes hates Liz. So first it is hates Liz. What will be the value of hates Liz? We consider that first. So we just write here hates Liz. What is hates? We take Liz, and it will actually be hates, we know, is the function, hates is a function, and Liz is the argument. What is this? We carry Liz there to the previous page and calculate the value of it. So for example, here is our hate, and this function hates works as we said that here this is the column of the people hated, and these are the haters, right? we know this. Now, this will take the object first, then this object, right. So, heights looks like this, and we are carrying, we have been carrying or rather we have brought QS from the old page, right, because our sentence, we are considering this construction heights less, right, which means this function heights. So, let us pretend that there is no height here, there is no height here. This is the function, like that is like we are considering this. So, heights now takes something, right. So, this is the heights function, and this takes less, or the denotation of less, which is actually QE. It's the abbreviated version for Queen Elizabeth II. And what does it yield? This thing that is considering that this is not there, this thing which is actually the denotation of heights less is actually this function, whatever comes out. So, QE it yields this function AS goes to 1 and QE goes to 0 and HK goes to 1. This function which we need to carry, that is 1 0 1. We just remember it is 1 0 1, and we bring it here, and then where is it? Okay. So, heights less will be 1, then 0, and then HK 1, right. Now, we can see that this now looks like this 1 0 1. It is because we are not considering just heights or less, we are considering heights less, which will look like this. Heights Hank will also be something like this, it will be a different thing here. We are not considering that, but we could have extended it, and we could have this also, but we are now considering heights less. So, heights less is this function, and this function will now be given to this function as an argument, that is AS 1 QE 0 and HK 1. Now, then what comes out is this function, which is actually AS 1. I'm copy pasting these values, and QE goes to 0 and HK goes to 0. Then what is, so this much we have done. So, basically we are now at so then what is heights less restlessly? It will be restlessly and heights less. Restlessly is the entire function, this entire function, and this gets heights less, which is this function. The result is this function. We just copy paste it. That is AS 1 QE goes to 0, HK goes to 0. This function, right? Now, what is my original sentence? Liz, sorry, our original sentence was Hank hates Liz restlessly, right? So, then what is the truth value of this entire sentence? That will be this restlessly. We have already got it, so I just erase it. It will now be actually hates Liz restlessly, which we have already calculated. that will take, we are considering this sentence, right? Hank hates Liz restlessly. So, it will take the denotation of Hank, and we know the value that is here. This will take the denotation of Hank, which is AS, and will actually yield 1, and that is required, because that was desired, because already we supposed that Sadie hates Liz restlessly, while Hank doesn't, right. So, sorry, I am wrong, I was confusing Hank and Sadie. So, the value Hank is HK. So, HK is 0. So, yeah, now this is the desired thing, I just correct what I said, although Hank doesn't. So, Hank doesn't hate Liz restlessly, and that is what we get as an answer, right. So, this is what we wanted also. This is how we see that this is fine, the way we have constructed this function. This has many other elements, but we have just shown that we have just shown 2 elements, one for this part for the VI's and this part for the VT's. So, we could add many more things, and we could see the entire thing, but now the second part of it, why we cannot have this rule, why this rule is wrong. Syntactically speaking, it sounds okay, it is apparently fine, but still it is actually very wrong. Why? Simply because we know that our assumptions were, we know that Liz snores restlessly is true, but Sadie snores restlessly is not true, right. We know these 2 things. This was our assumption. Although both snore, Liz snores restlessly while Sadie does not. This much we know. The problem is, if our analysis were like S goes to S and then ADV, the problem is, in this case the reference of ADV would take the reference of S. And then comes the problem, because think of 2 sentences. One, if we erase this much, you get, so 2 different things. One is Liz snores restlessly. The other one is Sadie snores restlessly. Sadie snores restlessly, right. And then in the first case, restlessly will take Liz snores. In the second case, restlessly will take Sadie snores. Now, so we know that this is, suppose this is whatever it could be. The truth values of these 2 things are different. The truth value for this is 1, and the truth value for this, Sadie snores, the truth value for these 2 things are the same, because both Liz and Sadie snore. So, they both are actually 1. So, whatever restlessly would yield after taking these 2 would be the same thing, because these 2 are the same. So, if had this been the analysis, both would give any truth value. If one is in that, suppose the structure of restlessly were 1 goes to 0 and 0 goes to 1. Suppose this was restlessly. In this case, so this was restlessly. In this case, it will take 1 and would yield 0 in both cases, meaning that it is not true that Liz snores restlessly, and it is not true that Sadie snores restlessly, because the first sentence is wrong. It is true that Liz snores restlessly, right? So that is the problem. The desired thing is this should be 1, this should be 0, but this analysis will not allow us to have that. So as we have tried to say, we have said here, since both Liz snores and Sadie snores are 1, restlessly would return 1 truth value for both, which is problematic, which we cannot afford to have. That is the reason this construction, that is S goes to S ADV, this construction is problematic. It will not differentiate between two different sentences like Liz snores and Sadie snores, and it will assign the same truth value to both these 2 sentences, which is not desired. It should assign to Sadie snores, it should assign 0, and to Liz snores it should assign 1. But because of this similarity and because of this structure, because it has to take this only, whatever it comes, this is a bad construction. On the other hand, we have seen that this analysis, that it goes to N and VP, and it goes to VP and ADV. This one is different because it works on the VP. It doesn't work on it works on the VP. It doesn't work on the S. That is the reason it determines the value at this level. Now this VP thing, like we have seen that in the case of Hank snores restlessly and Sadie snores restlessly, we have already seen that it will give us the desired result. So we are not repeating that, but this will be a big failure. So I just wanted to solve one problem, a practical thing the book gives, and then we could also consider a very short thing, consider this another problem. Suppose we have this question: give a syntax and semantics for the language like L0 except that prepositions are not analyzed into predicates and names. So what will be the structure of it? So I was just trying to have a very small specimen. So it is actually for logic. So you have these basic expressions, that is here you have just prepositions and they have their truth values. So the semantics of each I have given. So basically you could also write the semantic rules for just propositional calculus, where the propositions are not broken into predicates and subjects. Just prepositions also could. For example, in this 1 0 could be assigned to and it will give you 0, right? So that's what. So for example, if phi is a sentence, then neg phi is true if and only if phi is not true. Here the point is the basic expressions are not subjects and predicates, but they are rather prepositions themselves with truth values. Maybe we consider this in the next session, and then we start predicate calculus in the next session. Thank you.